Have you ever wondered why the North and South poles are freezing cold while the equator is scorching hot? Is it magic, a mystery, or is there solid science behind this temperature divide? Stick around, because today, we're diving into the real reasons why some parts of our planet shiver while others sizzle. It all starts with the sun, our planet's ultimate heat source. But here's the key: not all sunlight is created equal. At the equator, the sun's rays hit directly overhead, meaning all that solar energy is concentrated in one area. More energy equals more heat. But near the poles, sunlight comes in at an angle, spreading over a larger area. Less energy per square meter equals much colder temperatures. That's why tropical regions stay warm year-round, while the polar regions remain frozen. It's fascinating, right? The way the Earth is positioned in space actually dictates which regions get more or less heat. If Earth had no tilt, or if its shape was different, we might see a very different climate, atmospheric thickness. But that's not all. The atmosphere also plays a role. When sunlight enters Earth's atmosphere, some of it gets absorbed or scattered before it even reaches the surface. Near the poles, sunlight has to pass through more atmosphere because of its angle, meaning even less energy makes it down to heat things up. Think of it like a flashlight shining straight at the ground versus at an angle. The light spreads out and it's just not as intense. This is why, even when it's daytime in the polar regions, the temperature remains lower compared to the equatorial regions. Now let's talk about something super important: reflectivity. Ever noticed how wearing black in the summer makes you way hotter than wearing white? That's because dark colors absorb heat, while light colors reflect it. The same thing happens on Earth. The Arctic and Antarctic are covered in snow and ice, which reflect up to 90% of the sunlight that hits them. This is called the Albedo Effect. Meanwhile, forests, oceans, and land at the equator absorb most of the sun's energy, keeping things warm. So, the more ice you have, the less heat gets absorbed. And here's something to think about: as climate change leads to melting ice, more sunlight gets absorbed, which can further increase global temperatures. This creates a feedback loop that could impact the entire planet. But wait, there's more. Earth isn't just sitting straight up and down, it's tilted at 23.5 degrees. This tilt creates seasons by changing how much sunlight each part of the Earth gets throughout the year. In summer, the North Pole gets sunlight 24/7, but because it's still at an angle, it never gets as warm as the equator. In winter, the poles get no sunlight at all, which is why it can plunge to temperatures as low as -100 degrees Fahrenheit, -73 degrees Celsius. This tilt also means that different parts of the Earth experience different climate patterns throughout the year, leading to a dynamic and constantly changing world. Lastly, let's talk about oceans and winds. The ocean acts like Earth's giant heat distributor. Warm water from the equator travels toward the poles, while cold water from the poles moves toward the equator. This is called thermohaline circulation. And winds? They help too. Warm air rises at the equator, moves toward the poles, cools down and sinks, creating huge weather patterns that shape our planet's climate. These large-scale movements of air and water regulate temperatures across the globe, keeping things relatively stable. Call to action. So, let's sum it up. The equator is hot because it gets direct sunlight, absorbs heat, and has less atmosphere-blocking energy. The poles are cold because they get indirect sunlight, reflect most of the heat, and experience long periods of darkness in winter. Now here's a question for you. Do you think global warming could change this balance in the future? Drop your thoughts in the comments. If you enjoyed this video, don't forget to like, subscribe, and hit that notification bell so you never miss a science mystery.